Welcome back. The video today is all about distance between a point in a line and the distance between two lines. First, let's talk about how to find the distance between a point and a line. You must measure the length of the segment that's perpendicular to the line from the point. Also, you should know that if you are given a line and a point that's not on the line, such as line L and point A not on line L, then there's only exactly one line that goes through point A that's perpendicular to line L. And that's the line that we want to measure. So to figure out the distance from point A to line L, we're not going to measure this distance here. We want to go directly straight to line L with a perpendicular segment. So in order to find the distance from point A to line L, we will need to measure segment AB. Let's do an example together. I've already plotted the point in the line. Make sure you do the same. Now, in order to find the distance from point P to line L, I know I need to go perpendicular. Since line L is a horizontal line, I know that perpendicular is going to be a vertical line. So I need to find the distance from point P to, let's call this point Q. I know that distance for a vertical line is pretty simple. All I need to do is count how many units it crosses. 1, 2, 3, 4, 5. So the distance is equal to 5 units. Let's try another one that's a little more difficult. This time the line is slanted, so it's not going to be as easy to find the perpendicular. Plot the points first, make sure you label them. Now, since we want a perpendicular line, we're going to have to figure out what's the slope of the original line. I know that I can count rise over run. I see that this is going from left to right, it's going downward, so I know it's going to be a negative number. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 9 is the rise since I'm going down. And then I have to go over 9 units as well. So the run is also 9. This can simplify to negative 1. Now, in order to find this perpendicular line, let's talk about the slope of what the perpendicular would be. Refer back to previous notes, and you should know that the perpendicular line has an opposite reciprocal slope. The opposite reciprocal of negative 1 is positive 1. So in order to find the perpendicular from point C to line L, it must have a slope of positive 1. I can begin going to the right, however, that's not going to intersect the line. So instead, I'll go to the left, down 1 over 1 to the left, and I see that it intersects exactly at this point on line L. So I need to figure out what's the length of this segment. Let's call this point of intersection point B. I need to figure out the distance from C to B. Now, I can't just count this time, but I can either use distance formula or Pythagorean theorem. So if I'm using Pythagorean theorem, let's draw the right triangle. This side has a length of 4. This side also has a length of 4. And now I can use Pythagorean theorem, so I have 4 squared plus 4 squared equals CB squared. That gives me 16 plus 16 equals CB squared. 32 equals CB squared. Now in order to get CB by itself, I need to square root both sides. Normally I would do positive or negative, but I know that a distance is not going to be negative, so I'll only keep the positive form of the number. This can simplify. 16 times 2 is 32, where 16 is a perfect square. So I'm going to put that in the front. The square root of 16 is 4. So I know CB is equal to 4 radical 2. I could also plug this into my calculator to get an estimated answer, 5.657 units. So basically, point C is about 5.657 units away from line L. Just as a refresher, in case you need it, distance formula is this. Make sure you know this still from chapter 1. It's still very important. Pause the video and try the practice problem below. This is going to be the question we go over in class tomorrow. Now let's talk about finding the distance between two lines. So before it was just a point to a line, now it's two lines. To find the distance between two lines, the two lines have to be what's called equidistant. This word means that the distance between the two lines measured along a perpendicular is always the same. So no matter where you measure, it's always going to be the same. This can be used to describe parallel lines. Now here's a new theorem for you. It's called two lines equidistant from a third. It says this: in a plane, if two lines are equidistant from a third line, such as line J and line K, they're both the same distance, as you can see by these perpendiculars. They're both the same distance from line L. Then that means that line J and line K must be parallel to each other. Those two lines have to be parallel. Let's try an example of finding the actual distance between the two lines. So it's still going to be measured along a perpendicular. I already have the two lines drawn here. Line L and line M are actually both vertical lines, so this will be pretty easy for the first example. The first thing you want to do, remember, parallel lines, it doesn't matter where you measure between them as long as you're measuring on a perpendicular, because they're always the same distance. They're equidistant. So no matter where we measure, we should get the same answer. So I'll just choose this perpendicular down here. I know a horizontal line is perpendicular to a vertical line. This horizontal line is 2 units. Therefore, my answer, line L and line M, have a distance of 2 units apart. Again, just to reiterate, you could choose any 2 points to measure along the perpendicular. No matter where you choose, since parallel lines are equidistant, it doesn't matter where we measure, as long as we're measuring along a perpendicular. Alright, let's try an example where the two lines are not horizontal or vertical. This is much more complicated, so just be prepared. First, I need you to plot lines L and M. If you do not remember how to plot the lines based on the equations, go back to previous notes. Once you have the lines plotted, I would suggest plotting them in different colors. We want to figure out what's the slope of these two lines. Since they're parallel, they have the same slope. It's a slope of 2. Now, the next step is figure out what's the slope of the perpendicular. It would be -1 over 2. So this means go down 1 over 2 to find the next point from one point to another. Now we can either start on the blue line or the green line. And you want to start at its y-intercept. So I'm just going to start on the blue line, and I'm going to start at its y-intercept. So its y-intercept of the blue line is at y equals 1. Now, in order to form the perpendicular, I know I need to go down 1 over 2. Down 1 over 2, down 1 over 2, and so on. So I know that this is my perpendicular line. Unfortunately, on this example, the perpendicular did not intersect exactly at a point on the green line. This point here is where it's intersecting. So I need to figure out what is that point. In order to figure out that point, I need to first I need to figure out the equation of this gray line, the perpendicular line. So I know that that gray line, it must have a slope of -1/2. And I know that I let it start at the y-intercept of 1, so I know b must be 1. So if m is -1/2 and b is 1, it must be y equals -1/2 x plus 1. Now, I want to know when do the green and the gray lines intersect. So what I can do is set their equations equal to one another. I want to know when they're equal, so I'm going to set them equal in order to solve. First, add 1/2 x on both sides. Next, add 3 on both sides. Finally, divide by 2.5 on both sides. So I know so far that for this point, let's just call these points A and B. I know point A is 0, 1. So far for point B, I know that the x value is 1.6. However, I don't know the y value yet. I know that this point is on either the green or the gray line. So I can go back and plug in my x value to either equation, the green equation or the gray equation. So I see the green equation looks a little bit easier, so I'm going to plug it in here. So I have 2 times 1.6 minus 3. So I get that y equals 0.2. So now I know point B is at 1.6, comma 0.2. Double check on your graph if you use the straight edge. It should look pretty accurate. Finally, I need to find the distance from A to B. So using these 2 points, A and B, I can use distance formula. So I have the difference in the x values, 1.6 minus 0, plus the difference in the y values. It doesn't matter which order, I'm going to keep it positive, so I'll take the larger number first, 1 minus 0.2. So I have 1.6 squared plus 0.8 squared, all of that underneath the square root. You can type it into your calculator and you should get 1.789 units. Now just to review, first plot the lines. Find the slope of the 2 parallel lines. Next, find the perpendicular slope. Check on the line if it intersects the other line in a perfect point. So start on one line at its y-intercept and use the slope to find where it intersects the other line. If it intersects at exactly an integer right on the green line, you can go ahead and move on to distance formula. However, if you need to figure out what point B is, then you need to write the equation for the perpendicular line. Then to figure out where the 2 lines intersect, set them equal. That'll give you the x value. Plug the x value back into either equation to find the y value. And then finally, you can use distance formula between the 2 points. Pause the video and try the practice problem below. Alright, so it depends on whether you start at the y-intercept of the blue or the green line as to what your answer is going to look like here. So if you started at the y-intercept of 6, here's what your answer should look like. So if you started on the green line, this is what you should look like. However, if you started on the blue line at the y-intercept -5, you'll get the same answer, but you'll have a little bit different work in between. Here's the answer for that. Okay, I know you probably have questions right now because this is one of the hardest topics we're going to learn all year. So I need you to see what specific questions do you still have about goals 11 and 12, what we just did. Please write down a specific question. For example, a specific question might start with, on example 4, I don't understand what you did in step blah, blah, blah. All right? If you don't have any questions, if you're really getting this, you're good to go, please write a similar problem and solve it. That's all. This is the last video for the chapter. Great job.